Good morning, good afternoon, and good evening, everyone. Today we'll be talking about the new PTP 550E solution. I'd like to introduce today's presenter, Sagar Deshpande, who is the Associate Product Manager at Cambium Networks. So I'd like to pass things over to Sagar at this point.
Thanks, Olivia. All right, so today for our webinar, we'll be covering the introduction to PTP 550. This is the predecessor to the 550E is the PTP 550. So today in this agenda, we'll be kind of covering the overall PTP portfolio that Cambium Network has. We'll be focusing on PTP 550E introduction, talking about some of the key features, some of the new features about 550E. Next, we're going to talk about the release 4.5, which is the next upcoming release, and a very important feature called DCS that's going to be there. We'll also spend a few minutes talking about a case study that we had conducted over there, and provide a sneak preview on how to set the GUI and configurations and all that. Finally, we'll end it mainly with a comparison between the PTP 670, the PTP 550, and 550E. What are the key differences between them and how to choose the right products for them. Lastly, we'll be focusing on a summary of 550 and 550E and providing some more information. So here is the sub-6 PTP portfolio that Cambium Network has. So it's a diverse range of portfolio starting from the PTP 550, which is the multi-core dual band radio. We also have the PTP 670, the PTP 700. Those are the industrial grade products. We also have EPMP 4316, which is based out of the 802.11 AC chipset form. Similarly, we have the EPMP 4319R. We also have EPMP Force 325. So the 300-16 represents 16 dBi. So that's the antenna gain. The 19R represents 19 dBi antenna gain. The Force 300-25 represents the 25 dBi antenna gain. We also have a PTP 450B, 450I, which comes from the 450 lineup, 450 platform. And we have a EPMP bridge in a box. So introducing the PTP 550, the frequency range for this one is 4.9 to 6.2 gigahertz. The channel it supports is 10, 20, 40, 80 megahertz channel sizes. The spectral efficiency is 8.75 bits per hertz. With respect to interface, it mainly has two interfaces. One is the gigabit Ethernet, which is for data and power, and the other interface that we have is the SFP or fiber port. This radio can do from QPSK to 256 QAM. It has an aggregate speed of 1.36, 1.4 gigabit per second. This is aggregate, which means it's to and from. It has a split frequency approach, which means because the 550 has two radios built in, you can have different frequencies operating at the same time. The output power is 27 dBm at BPSK, so it provides a wide range of this one. The antenna gain is 23 dBi. Latency is about 3 to 5 milliseconds in one direction, and it's a IP67 housing. Some of the key features for 550E is dynamic channel selection, or the ability to jump frequencies when they're running into interference. It also has 256 subcarriers, which helps with multipath interference. It supports near line of sight and line of sight applications. It supports channel bonding, which we will cover in the next few slides. And we do support CN Maestro, which is our cloud platform from which you should be able to manage all Cambium Network products. We also support VLAN and QoS, some of those networking features. The 550 mainly comes in two flavors, as you can see in your screen. One is the connectorized version, the picture on the left, and the integrated 23 dBi radio, which is on the right side of the picture or the center of the picture. So the key difference between people who are familiar with 550, it's been there for about 2 years now. The key difference between 550 and 550E is the operating frequency range. The 550 starts around 5.1 of the 5.15 frequency to 5.9, whereas PTP 550E starts from 4.9 to 6.2 gigahertz. The 550 is available in all ranges, which is FCC, IC, HC, and ROW SKU, whereas 550E is only available in HC and ROW, which means it will not be available in US and Canada. One of the key reasons for this one has to do with regulatory type approvals that go along with these changes, and the 550E does not support that. From RF performance, there's no difference between the 550 and 550E. Essentially, it's the same, be it high capacity, the types of channel size support, the throughput, or the interference level that it mitigates as well. Dimensions also are exactly the same. They share the same housing. The max throughput is also common between them is 1.4 gigabits per second. The 550 mainly has two main strategic advantages. One is the 4.9 frequency band, which is a public safety band, in which some of the compliance requires one band to be 4.9 and the other one to be a 5 gigahertz. 550E is an ideal fit. And the other one is there are many countries where 5.9 to 6.2 gigahertz are open. For example, Eastern European countries and some of the Middle Eastern countries where 5.9 to 6.2 is open, and 550E does not solve that problem for those customers. So 550E was introduced to resolve them. So channel bonding explained. Okay, so the difference when you have two 550 or 550E, in each 550 you have two radios built in. In this case, the picture on the bottom right, we have a link between two PTP 550 or 550E. You have channel A and channel B connected, and each of the channels can operate between 10, 20, 40, or 80 megahertz channel sizes, independent of each other. So that gives us a broad variety of channel combinations, which is on the left table that you can see. Starting from the lowest, 10 megahertz channel size, you should be able to get 166 Mbps, and with all the combinations you can go up to 80 megahertz to provide 1.4 gigabits per second. So you can kind of see it gives a wide variety or diverse options for consumers to choose specific channel sizes they want based on their current RF conditions, or if RF conditions changes over time, it should be able to do that. Next, the PTP 550E supports adaptive modulation, which means there is no packet loss when the radio transitions between different MCSs. Which means if a packet is currently working at MCS 9, it may jump from MCS 9 to MCS 6 without any change in modulation or antenna pattern for the 550E. It is 23 dpi antenna gain. The beam width is about 8 degrees, and the dimension is about 12 inches by 12 inches, or 1 feet by 1 feet in dimension. The 550E is IP67 proof, which means it has protection against solar, hurricane winds, dust and weather protection. It's known to withstand harsh conditions as well. The PTP 550 also supports PTP sync. We use that using two options we have. One is CMM5 that many customers are already familiar with, and also using our CN Pulse, which is our new introduction, which we introduced late last year. So just to kind of explain to folks what PTP sync issue is, or why do we need to focus on that. So we have a simple scenario diagram. So on the top of a building, you have two radios next to each other who are transmitting to two other radios which are fairly far apart. If the TX and RX cycle between on the two radios on the main tower are misaligned, they will interfere with each other, because when the first radio is transmitting, the other radio is receiving, and because the transmitter is so close to the receiver, all noise will be heard from the no. The second radio cannot make sense because the first radio next to it is transmitting at a very high dB power. So to counteract with this, we have PTP sync options, which will ensure that the TX and RX cycles are aligned with the radio so that they don't interfere with each other. Ideally, we use PTP sync when we have limited spectrum available on a tower. So of course, if you have a lot of spectrum available, you may want one radio to operate on, both the radios to operate on independent channels so that they never interact with each other as well. Some of the key security parameters the 550E supports is prevents prevents unauthorized software or modified software cannot be loaded. Second one is we have AES encryption of AES 128, and each release that we have is thoroughly tested with industry standard tools, and we also have multi-level authentication for this one. So another one advantage or another key feature for the 550E is the uplink downlink ratios. It has the three main options, which is 50/50, 70/30, and 75/25. And these are the throughputs which you can see in the bottom side of the screen. So you have 650 Mbps uplink, 680 Mbps downlink. This is in 50/50 configuration. And 70/30, you have close to 950 Mbps uplink and then 400 Mbps downlink, and vice versa for 75/25. So here is the key roadmap for 550E and 550. Both of them will share the same roadmap because the hardware is very similar. So just to kind of reiterate from the past, we had introduced release 4.4 in August or Q3 of last year, which focused on QoS and DFS tuning and VLAN and some of the key feature sets. In Q4, we provided us a stability improvement release. Now the big release coming up in close to end of Q1 is the release 4.5, that we have three specific advantages. One is the ePTP low latency mode. This is similar to the ePMP platform based on the 11N. But ePTP mode will ensure that low latency is only available on single channel, because there are two channels operating on the 550E. It's not possible that both of them can have ePTP. So if you want to enable ePTP for low latency, you have to only use a single channel. That's only supported there. The second one is you have the support of 10 megahertz. So far, only 20, 40, 80 megahertz were available. And now with our beta release, which we already have available on our support page, which I'll get to, you can download the beta firmware, and then in that you should be able to try and use 10 megahertz channel size. The third one is a big important feature called DCS, or dynamic channel selection, which we will be covering a little bit more detail in the next few slides. I want to also focus on a couple of key scenarios or cases we have for 550 and how it 550E and how it plays into it. So one option, because 550E has two radios, is you can have one radio which is reliable and the second radio which is aggressive. By what I mean by aggressive is it can operate in a band which is prone a little bit to interference, or it has a lot of interference built into it, because you have the peace of mind that the second radio is working on a lower channel size, but it's on a reliable this thing. So you get the best of both worlds, where you have a stable 20 megahertz channel in 5.1 band, and you have an aggressive 40 megahertz on channel B. So you're trying to grab as much frequency as you can, whereas kind of keeping a safe and secure link. The next one is DFS Non DFS. So DFS, as many people know, is mainly for radar. This is mainly in the 5.4. It depends from country to country. So in HC, it's 5.4, 5.8 bands as well. But basically what it means is, if you are operating in this frequency or range, and if there is a radar detected, the radio is mandated to shut off for 30 minutes or so. So basically your entire link goes down. But with 550E, you have the advantage that there are two radios built in. So even if one radio goes down, the other radio continues to operate, because you would have probably used it as a non-DFS network. Most of the other products out in the market cannot use this feature, or because of this, they don't use the DFS band, which is most of the time it is empty, because of the off chance that a radar balloon, or weather balloon, or a jet or someone comes by and they have to shut down their network for 30 minutes. So having this ability of two channels, I think really improves utilization of the DFS bands as well. Right. Okay. So now I'm going to spend a few minutes talking about DCS, what it is and how it operates. So DCS is a feature mainly which is used for automatically changing channels, or the frequency channels, to avoid interference without dropping the link. Right. The channel size that it can use is 10, 20, 40, 80 megahertz. You can hop across the bands, which means if you are in 5.1 band and if you find a really good channel in 5.8, the radio will switch off on 5.1 and automatically come on the 5.8 band without any loss. So it's not just within the same band that it operates, it can operate on any part of the spectrum. The spectrum scans basically continuously, and that provides the main input to the radio. The 550E also, DCS also proactively scans the entire band to give you a live update on how the radio is performing and how the interference level is. It also provides the data in GUI form, which I will show you in the next couple of slides. The DCS is always active in the background, because the 550 has a spectrum scanner, it is always picking up the current channels or current spectrum around it, and it's able to determine which is the best next best frequency hop that it can do. All the configurations can be enabled from the GUI, and DCS can also be monitored at all times. It has a bunch of options that you can use to change. You can also specifically select a specific channels or center frequency that you want to be selected. So another way to explain it is, let's say on the top half of the picture you have a master slave radio, and it's operating between 40 megahertz between 5200 and 5240, and for some reason you find interference on this band, and so then what happens, DCS kicks in, and without changing the or without losing any packets, the radio automatically switches to 5800 to 5840. Similarly, if you're operating in a DFS band, the 5500 to 5540, and if it detects a DFS, automatically the radio comes up in the 5800 to 5840 band. Without the radio is mainly optimized for highest throughput, the switching concept, and our main focus is to never drop packets during the transition. So we did a case study. This is in Indonesia with HTS Net. They're a prominent ISP provider in Indonesia, and they wanted to try their DCS in live link. So the test scenario that they had set up is running a 550 link using live traffic. This is their actual network they had been using 550 for a long time, and they wanted to see how DCS would perform on their live network. So what they did was mainly use 220 megahertz channel, and they conducted the two tests which would be conducted over 24 hours. And in the first test, they would run the non-DCS firmware release 4.4, which is available. And in the second test, they would run the DCS firmware beta firmware release 4.5, which is also available on our support page. And each of these test cases would be run for 24 hours over live traffic. So this is to give an indication of how the radio would outperform on any given day, how much throughput can be changed. So here are the results. I will kind of spend some time diving a little bit deeper into it. But the overall result is 17% improvement in DCS with improvement in throughput with DCS enabled. So basically, with the exact same link, with the exact same scenario, with just switching on a key feature called DCS, you're able to improve your performance by 17%. I think that's a really good appeal for using DCS, especially in a crowded environment whereas this link was in the middle of a city. So it was really useful that without any changing of a button, by just upgrading a firmware, you're able to improve your overall capacity. The frequency hop, which means how often the frequency hop was happening, was about once every 3 minutes, which actually tells you how bad the interference would have been for the radio to continuously switch once every 3 minutes. And keep in mind, this test was run over 24 hours, so it's close to 200 or 250 hops that it would have had in its entire journey. Also, the radio was able to achieve higher modulation compared to this one. So on the table one, you have two main circles. So so on the scenario one, you have without DCS, so you can kind of clearly see that the MCS 9, MCS 8, MCS 7, MCS 6 is set to 0%, which means none of the packets are crossing MCS 5, which means it's a stable link. Right? It's a solid link, but it's never crossing that MCS 5 threshold. Whereas in scenario 2, with DCS and radio 1, you can clearly see that the radio is trying to push the limit, trying to optimize as much as it can, and try to reach higher MCS levels. So you can kind of see it hits the MCS 9 at least 4% of the time, and it tries to maintain MCS 7 and MCS 6 about 35-36% of the time. So it clearly tries to perform much better. So the weighted average that we get, which is on the bottom total, we see if the DCS without DCS was run for 24 hours, an average you would have gotten a 230 score, and with DCS you would have gotten a 251 score. This is with respect to percentage, so it doesn't truly reflect how much data was sent in, but this represents how much percentage of the time you're getting a higher modulation rate. The same thing can be observed with radio 2 as well. So you're seeing in without DCS you have 192, and with DCS this saw a really nice improvement of 262, and the same you can observe. So in radio 2 the radio spent less than 1% in MCS 876, whereas over here you can clearly see it's doing a lot of basically the radio is trying to push the limit, trying to switch to a better channel and trying to hustle for you for the based on the current interference. Now, quick setting point of or configuration point of view once you download the firmware is how do you set the DCS in GUI. So if you go to the tools, if you go to the radio, you go to tools and dynamic channel selection, it is enabled. The first thing you have to do is enable it. And then you have three main options that you have to configure, and each one has its own reason why you have to choose. We also have logs in case you want to switch back or if you want to change as well. So once you enable it, assume all channels get allocated and approved. Then you have to select what should be your signal to noise ratio between the diff. So what this number means, or this indicator means, is what is the minimum difference you need to have between your current channel and your next best channel. So if your next best channel is, let's say, 5 dBm better, switch, right? Because you don't want to have a ping pong effect if this is very low. So if it's 2 or 3 or 4, sometimes it depends on the RF conditions. You don't want it to be continuously ping ponging between two sides. So you may want to keep it a little bit higher, around 5 on 7s, which means there's a solid couple of MCS levels that you can jump. Only then it makes sense. Then you should use it. What is the hopping interval, which means how often should you hop? So there are some advantages to hopping soon, and there are some advantages to hopping late. Hopping soon basically allows the radio to hop fast, especially in high interference conditions. So instead of just getting stuck in a bad channel for, let's say, 300 seconds, if the radio is configured to jump every 90 seconds, if there's a lot of variability, keeping it lower makes a lot of sense. But for high interference conditions, I would keep a lower hopping margin. What is the third one is the throughput threshold drop. This one mainly means uh, when the throughput degradation occurs, this will trigger a switch. So which means, let's say you're at 500 Mbps capacity, and suddenly your throughput drops to 540. So that's definitely a 10% trigger that will ensure that the radio thinks about DCS and jumps to a different channel. Right. So these are the key main three things that you have to consider when setting and configuring the radio. Next part of the configuration, it's not mainly configuration, it's monitoring, is we actively provide the quality of all the channels that are available. So in this case, if you go to monitor and DCS, if you click here, you can kind of see all the channels that are available that are selected, and the quality, the current quality, this is in real time, this gets updated. And in case you have had the link active, you can see how many times it's been hopped, how many times it's been unsuccessfully hopped, how much data is used, etc. So there's a lot of information that you can reuse to understand your network and see how the radio is performing and tune it accordingly. Okay, so that's about DCS. I would highly encourage everyone to just download the firmware and try it out for themselves, because just to see how the radio would perform just with a key firmware upgrade. Right. So the main difference between PTP 670 and 550 550E is the 670 is mainly built for industrial products. So it has a lot of key features such as 1588 timer, HCMP, which is high capacity multi-point, which means it can be used for point-to-point and point-to-multipoint. A lot of encryption and security features. The 550 and 550E is mainly built for speed. So it's mainly built for high capacity speed and doesn't offer too much of extra feature sets. So let's start off with the frequency covered in PTP 670. The frequency band supported is 4.9 to 6.05. The 550 supports 5.1 to 5.9, and 550E supports 4.9 to 6.2. The max throughput is 450 Mbps, whereas 550 supports 1.4 as well as 550E supports the same. You can see the spectral efficiency is higher for 670 compared to 550, which supports 8.7. And there are definitely more channel sizes supported for 670 compared to 550. However, the max channel size supported for 550 is 1.6. Both the radios or all three radios support some form of DCS or DCO, which means in case of interference, the radio switches from one side to the other, one band or one frequency band to another frequency band. Oops. Yeah, so 670 also supports jumbo frame, whereas 550 and 550 do not. And all the radios support some form of TDD sync. Just to summarize on a high level, the 550 and 550E is a 1.4 gigabit capacity radio. It has asymmetric non-adjacent channel bonding, which means you can have two channels which are not required to be adjacent to each other and which can be asymmetric, which means it can be 10 megahertz and 20 megahertz or 40 or 80-20 or any of the combinations. It is also asymmetrically modulated, which means channel A could be operating at MCS 250, MCS 9, or the highest modulation, whereas the second radio, completely independent to each other, can operate, let's say, at MCS 4 or MCS 5. So they're not tied together. So this is a really important distinction and advantage, because you want them to be as much independent as possible, because if interference happens on one radio, it should not affect the other radio. Right, so keeping them independent is very important. Next one, the 550 supports a fiber SFP port. This also is supported by 550E. So in case you want an Ethernet port, we have that, or if you want a fiber port, we also have that. We support ARQ protocol. This is a protocol wherein which you send an ACK once a packet is sent across, and it has a very small form factor and has a metal enclosure, which means durability is long lasting. Every time you buy a 550, it comes in form of a kit, and then in a kit you have a radio, which could be 550, 550E connectorized or integrated. You have a power supply, you have a mounting bracket, and you get a line cord depending on which SKU or range you choose. Right. So for more information, I would highly recommend going to our cambiumnetworks.com website. Also, I would encourage everyone to visit our community forum, where we answer all the questions, including any upgrades they have or new firmwares we have, or any issues they're running into, or if other customers would have run into those issues. I'm pretty sure you can find them on these forums. I personally am on the forum and I check for questions every day. And a lot of the development team is also on this call. We try to answer these questions as soon as we can. Right. For more information in this one, we have the community. It provides more input from forums to core knowledge base to ideas to your stories. It makes a lot of difference, and also follows us on social media. And thank you. I would request everyone to put in their questions, and I can try to answer them one by one. So I have the first question already here. Can DCS work in the same band? Yes, the answer is yes. So you can have two radios. Let's say you're operating in US, which has in 5.8 band. You can have both the radios in the same band, and you can have them next to each other as well. I do not recommend them having next to each other. The reason is they may cause slight interference, but it should not be much of a problem. But in case you have no other choice based on RF constraints or regulatory issues, you can put the radios next to each other, and they should still be able to operate. So yes. Next question is, does the 550 also have built-in Wi-Fi chipset? The 550E does not have a Wi-Fi built-in chipset. It has a Wi-Fi chipset, but it's only used for spectrum scan. You can't connect to it using a phone or configuring it via that approach. But you can. But it has a spectrum chipset for just for scanning. I have an interesting question. Say, would DCS affect latency? The answer is no. The reason I say no is because the 550 has two radios, right? So the mechanism implemented in this case would be the first radio goes down. Before it goes down, all the traffic is moved to radio 2. And once the radio goes down, it already knows which radio it has to come up. So maybe there's a momentary lag by the time the radio comes up, but that's more than enough because the radio 2 handles all the traffic. And once the radio 1 comes back online, the data is transferred back. So ideally, the way we have designed it, no packet should be lost. There may be a increase a little bit in latency because a lot of packets may be going through one of the radio versus the other, but that's momentary. So our typical DCS swap happens in less than 100 milliseconds. That's the worst case. Depending on RF conditions and how this thing, it's probably within 50, 60 milliseconds. So it shouldn't make much of a difference in overall performance. So there may be a small blip with respect to latency, but our main objective is not to lose any packets along the way. There's a question from Mike, is this available in US FCC? So I'm assuming you mean PTP 550E. The answer is no. We have the PTP 550, which is available in US. It has the same feature sets, but the 550E is only available in rest of the world and EU. This is due to some regulatory compliance, which the 550E does not comply with. But all the features such as DCS, uh, 10 megahertz, 20 megahertz, all the except the 4.9 band, everything else is available in 550. That should be available in the US. Okay. Thank you so much for attending. Please visit our website, cambiumnetworks.com, and if you have a question, please email it to me. Thank you so much.